Fourth video from K8BYP on grounding and the electrical code. We just left Article 250 and now we're in Article 800, which the grounders, so to speak, refer to when they say every ham antenna and every ham station must be grounded without any ensuing explanation of why or the physics behind that. This article is where the references to CB and amateur radio stations are. It is a dire mistake to skip over to those chapters without starting at the beginning. Article 800, Communication Systems. Right up front, grounding. And right up front, what is easy to skip over by someone with an opinion or agenda or who have opinions on what this topic is and are simply pointing to the code to justify their opinions. What they will miss when they jump over to the section on amateur radio is this diagram, which is critical. And this diagram is where ham radio operators and stations routinely, grossly violate this electrical code and create possibly dangerous conditions. This article mainly covers larger communication systems, particularly CATV, community antenna television, telco, telephone, intercom, computer wiring. Those are characterized by, wiring with great length, great capacitance, and a lot of that length that runs in parallel and close to other conductors energized by power main energy. CATV systems are notorious for severe lightning damage, and realize they run on the same poles exactly parallel with the power service, the commercial power service to the transformer, and also generally along from the transformer to the house, for example, along with the 3 feeder conductors. But what's critical in this diagram is to understand that there must be a bonding conductor between the communications equipment on the right and service equipment on the left, and service refers to commercial power service. There's a ground at the service entrance. See? Power service, grounding electroconductor. And the code here presumes that the communication system also has the ground, and it is absolutely mandatory to have those 2 ground rods properly bonded together, else it is a gross code violation and dangerous. This is where hams go wrong with grounding. There's a ham near me that took the advice of one of these self-proclaimed experts in grounding and put a ground rod about 100 feet, this one, about 100 feet away from the service entrance ground. And you know what he had for a bonding conductor? The antenna coax. And guess what happened when lightning hit the ground at this ground rod? And he showed me where it hit. What it did was created a very large current through the earth here. These 2 ground symbols imply that there's earth resistance between the 2, and generated a very high voltage across the feed line. He was lucky he didn't lose all his equipment. Moving on to a couple sections of interest. 800.53 lightning conductors, where practicable, separation of at least 6 feet shall be maintained between communication wires and cables on buildings and lightning conductors. This goes to imply how extreme the magnitudes of lightning discharge currents can be. This implies the fields that they can generate that can be coupled into other conductors. Here's where the grounder will swear up and down that all ham radio antennas, all ham radio stations must be grounded, and they'll point to this, 810.3. Coaxial cables that connect antennas to equipment shall comply with Article 820, which is covering CATV systems. It's very important not to take this out of context, not to take one sentence without reading the headings and what came previously in the chapter. Now this is an article covering radio and television equipment, including amateur, right? So this sentence says that everything that a ham touches must be grounded, right? Well, it doesn't say that. Do we see where it says that a radio transceiver must be grounded? No, we do not. Remember the diagram I just showed you? Where's a radio transmitter connected? It ain't connected to the antenna ground, it's connected to the power service ground by virtue of using building power. This does not say that every coax cable must be grounded. It implies that when there is coaxial cable connected to an antenna, and when it's grounded, it shall comply with Article 820. 810.15, apologize for the video here. I'm cheaping out on a cell phone. 810.15, grounding. Masted metal structures supporting antennas shall be grounded in accordance with 810.21. There are mechanical specifications, there's ground wire sizes, etc. That's fairly obvious. It doesn't say why. It's obvious for lightning discharge. Put up a great big metal pole. It's the elephant in the room. It's going to, so to speak, attract lightning. If you recall the 6-foot spacing requirement, and that's stated as a requirement further on. The previous statement was where practical, but the next statement is a requirement. Put 8-foot pipes in concrete. Put a 100-foot tower on top of the pipes. It is ludicrous, it is contradictory to drive a ground rod because the tower is already grounded. The code provides for grounding conductors encased in concrete, and that's generally what legs poured in concrete of a tower are. So what that does is establishes a tower as a lightning conductor. Therefore, the previous paragraph that required a 6-foot separation then requires the coaxial cable and rotor cables to be spaced 6 feet from the tower. Do you know of anyone that does that? Nope. I don't, and you don't. They're violating code when they strap the feed line to the side of the tower with electrical tape. And everybody does it. Failing to realize the physics going on here. When there's a 1, 2, 5, 10,000 amp lightning transit going down the tower, it is tightly coupled into the feed line both magnetically and electrostatically because of the PVC dielectric on the outside of the feed line. Clearances, receiving stations. Clearance between leading conductors and conductor forming part of a lightning protection system shall not be less than 6 feet. So we got to run that feed line 6 feet off the tower, or you're at terrible risk. This is 810.21. Run in a straight line. This is a critical point. I bought an old house here. I found that the number 6 ground wire from the conduit down to the meter box was underneath the concrete thing that catches the gutter water. That's a universal sign that somebody tried to hide the fact there's no ground rod. Because if there's a ground rod, that concrete thing won't fit over it. I pulled the concrete thing away. Sure enough, somebody had stuck the wire down in the dirt. So I put a ground rod in. I straightened the ground wire from the top at the weatherhead all the way down. Installed a commercial bonding clamp on the conduit after scraping the paint off the conduit. Cleaned the ground wire. Ran it with a very smooth 3-foot radius to the ground rod. And happened to call the electrical utility a while later to do a disconnect so I could work above the lines. And they looked at that and they said, whoever installed that ground knows the code. And I said, thank you, I did that. The bonding conductor or grounding electroconductor for an antenna mast shall be run as straight a line as practical. Bending a ground wire is a disaster because that causes crowding of the field lines in the bend and causes an increase in inductance. And when a transient hits that, it sees as an RF choke and creates a high voltage. Here's another part of the code that's violated. Recall back in the twin lead days, and hold on to that term twin lead, it's important here. Back in the twin lead days, we ran a 300 ohm line down the house with these standoffs we bought at Radio Shack. They thread inside the house, have a plastic knob, put the twin lead in, turn the knob to lock it in. There's a 3-inch requirement. clear the surface of the building on non-absorbent insulating supports such as pins or brackets, blah blah blah. Entrance to building. Except for protected by continuous metallic shield, the braid on a transmission line is not a continuous metallic shield. Our feed lines at best are about 85% coverage. That is grounded with a conductor, yada yada yada. Lead-in conductors, plural, shall enter by one of the methods, etc., etc. This implies a pipe, not the coax shield. The coax shield is another conductor of these plural conductors, as in lead-in conductors, and both of them, according to this paragraph, must be in a metallic conduit, unless it goes through the wall through, like I'm doing here, number 1, a rigid, non-combustible, non-absorbent insulating tube or bushing. I put up a commercial weatherhead and piece of PVC pipe through the wall, through an opening with 2-inch clearance, or through a drilled window pane, which is glass. This isolates a conductor that's hit by lightning that becomes extremely hot from combustible surfaces. Antenna discharge units. Each conductor of a lead-in. They keep referring to this term lead-in. This is a mistake. There are several significant errors in this section of the code, and one of them implies that ham radio stations are permitted to use transmitters, which we are not. I'll get into more details on that later. We don't have transmitting stations. This implies commercial broadcast. Amateur radio operators are not allowed to broadcast, and transmitting station is a broadcast station. It is the only requirement in here that's stated is here in 81057 that we ground for static charges. There is no requirement in this section whatsoever, not in this article whatsoever, that requires grounding antenna systems or radio gear for lightning. And the reason is the engineers that create this code know better. End of video 4.